Hey everyone, thank you for joining us again, and welcome back, as this time we're opening up the conversation on how to compare three or more means. Well, heading into our objective then, we need to be able to test a hypothesis regarding three or more means using a one-way ANOVA test. Well, the one-way analysis of variance, which we call ANOVA, is an inferential method used to test the equality of three or more population means. Let's highlight that one more time. We're discussing three or more means right now. First, the parameter we're discussing are means. That way we keep that mentally separate from the test on proportions. And second, it's three or more population means that have us using the ANOVA test. As we've discussed how to compare two population means, that's when we used our two-sample t-test. Well, first we have some requirements for this ANOVA test. The idea is, though, that as long as these are satisfied, we'll be able to jump into the ANOVA test, and for the classroom setting, they'll go ahead and be satisfied, so we don't have to worry so much about them. Instead, let's jump into the idea of the ANOVA test. Well, what's going on is, our null hypothesis here is that all three of the means from our three populations would be equal. And if the null hypothesis is true, we'd have three distributions that basically overlap each other, since we have normal distributions with the same means. However, our test is to find out whether at least one population mean is different from the others. Now let's make sure we're careful on that. Our diagram shows three different means. However, that's not our actual alternative hypothesis. The alternative hypothesis is simply that at least one population mean is different from the others. It may be that mu1 is equal to mu2, but if mu3 is different, then that means we get to reject the null hypothesis, like we've done with other hypothesis tests. Well, let's head into the steps on how to conduct this hypothesis test then. First, our null and alternative hypotheses don't change. The null hypothesis is simply that however many means we're working with are equal to each other, and then the alternative hypothesis is that at least one of these means is different from the others. Remember, we're comparing three or more population means, so we could have 4, 5, 6, 14, who knows. After stating our hypotheses, we need to calculate the test statistic F0. We've worked with the F statistic before, but look at this beauty of a formula that we've got here. That might be the most beautiful formula of our semester. However, in case it's causing your blood pressure to increase a little bit, we're actually not going to make you find this by hand. Instead, we'll just use the calculator function to conduct our hypothesis test. If we were doing this by hand, we would find the p-value using the FCDF function, but like we said, we'll have an ANOVA function on our calculators to do this, so you don't have to worry about that too much. Instead, we want to reiterate one more time. If the p-value is less than alpha, hopefully by now we know to reject the null hypothesis. And then note, when we reject the null hypothesis when doing an ANOVA test, we are rejecting the assumption that all of the population means are equal. However, we don't know which or how many means are different. That's not really what we're assessing. We're just saying that at least one of them is different. So let's go ahead and jump into our example then. We're told the following data represent the weight in grams of pennies minted at the Denver Mint in 1990, 95, and 2000. We're told to compute the F statistic for the penny data, but here's the important part of the sentence for us, and test the hypothesis of equal means at the alpha being a 0.5 level of significance. To test the hypothesis of equal means, we recognize that we've got three populations here. Population 1 being the 1990, and we're going to throw those values into L1. Population 2 being 1995, so we'll throw those into L2, and of course that means 2000 would go into our L3. And since we're conducting a hypothesis test on three or more means, we know we're using the ANOVA test. If that's okay, let's start out by stating our null and alternative hypotheses. We know our null hypothesis would be that these three means equal each other, while the alternative hypothesis would be at least one population mean is different from the others. Well, now that we have that set, let's go ahead and throw our data into L1, L2, and L3. And once you're there, we're going to jump down to the calculator portion of our notes. On our calculators, we're looking for the ANOVA function, and hopefully we're comfortable with it by now. We need to hit stat, arrow to test, and then find our ANOVA function. We see the instructions on the notes, so let's go ahead and jump over to our calculator. Repeating those instructions one more time. I'm going to hit stat, arrow over to test. If I hit the up arrow, it looks like my last option is ANOVA. So I'm going to hit enter. Remember, we put our data in L1, L2, and L3, so we input ANOVA L1, L2, L3. Once you're all set, go ahead and hit enter, and our calculator spits out all the information that we need. Now, we're not getting terribly deep into the specifics of the ANOVA test, so we have this other information like factors and errors if we continue to arrow down. But since we're just giving an introduction of this ANOVA test, we really care about the F statistic, and there's our p-value. And if we're all set on the calculator, let's head back over to the notes. Heading back to the notes then, from our calculator, we found our F statistic to be approximately 1.395. We got a p-value of approximately 0.2634, and we know to compare that to our alpha that was set at a 0.05. And since our p-value is greater than alpha, we know that means we do not reject our null hypothesis. Heading over to our conclusion then, we just said we do not get to reject the null hypothesis, so that means we know there is insufficient evidence to support the claim that the mean weights of the pennies differ in at least one of the samples. Just putting emphasis one more time, remember the alternative hypothesis is simply that at least one of the means differs. And in this case, we did not have enough evidence to say that at least one differs. And that means we're all set with our ANOVA test. And before we wrap up the conversation, just one quick follow-up. In homework, we may be asked to generate a box plot of each list of our data to support these results obtained from our hypothesis tests. We can do all three of these box plots simultaneously. To do so, we turn all three of our plots on, and then we use our data from L1, L2, and L3 individually to make our box plots. We'll show it in the calculator in a second, but just focusing on the concept at the moment, we end up with this as our image, and notice that all three box plots are in the same ballpark, which coincides with our hypothesis test results that the means were not significantly different, and that's why we could not reject the null hypothesis. Heading over to our calculator just to make sure we're comfortable with making those box plots, we're going to hit second and then the y equals button to get into our stat plots. Notice that right now my plot 2 and 3 are turned off. We're going to turn those on in a second. One way to do so is to hit the option 5 and then enter, but we'll just do these individually. So first I'm going to hit enter into plot 1. It's already turned on. We have a box plot that we want showing the outliers as well, and the data would be from L2, so we're all set there. Then I'm going to hit the up arrow to get into my plots, and I'm going to hit right so that we can highlight plot 2, and if you hit enter, it will switch over to plot 2. Now I can hit enter again to turn plot 2 on, and notice that my X list is already L2, the box plot is already activated, so we're all set there as well. And then I could hit up arrow one more time, arrow over to plot number 3 and hit enter, and now we can turn plot number 3 on. With plot number 3 on, I already have my X list as L3, box plot is activated already, which means we're all set. We get to hit zoom, and like we've done before, option number 9 would be our zoom stat, so you can just hit 9, and there's our graph like we saw in the notes. Which means one more time, we're all set with our discussion on the ANOVA test when we're comparing 3 or more means. And thank you one more time for joining us.